Okay, we have limit of, nice, x squared minus 3 over times absolute value of x minus 1 times sine of x minus 1 over sine of x minus 1. Well, the first thing you notice is that I can x squared minus 3 absolute value of x minus 1 over sine of x minus 1 as x goes to 1. So I can use product rule, product law, hoping that this second piece also has a limit. So I don't know, but I'm hoping that it will have, then I can do this thing here. Yes. Why I'm separating this piece here? Because I know how to evaluate this guy. That is limit of a polynomial, and in polynomial, substitution is what you need to know. In other words, polynomials are continuous. Finding limit is the same thing as evaluating the function. So it will be 1 squared minus 3 times limit of absolute value of x minus 1 over sine of x minus 1 as x goes to 1. One thing that I always say is that if you're dealing with a function with a piecewise defined function, you have to work with right and left limit. So that's the fact. So working with piecewise defined functions, we need to use one-sided limits. While you right away come up and say, where is piecewise defined function? Well, absolute value of x is piecewise defined function. For x is bigger than or equal to 0, it's x. For x is less than 0, it is negative x. How is it related to my function here? Well, if I replace x by x minus 1, so x minus 1, I have to replace everything by x minus, every x with x minus 1. It will be x minus 1 bigger than or equal to 0 minus x minus 1, x minus 1 less than 0. Well, let's just simplify a little bit this guy. So this will be absolute value of x minus 1. You see, instead of writing x is bigger, x minus 1 is bigger than 0, I can write it as x is bigger than or equal to 1. And for this one, I can write minus x plus 1. And here I can write x less than 1. So that is the second piece. Okay, this is just absolute value of x minus 1. How about my function? Okay, so you divide the whole function by sine of x minus 1. So in other words, divide all the terms here by x minus 1, by sine of x minus 1. So x minus 1 sine of x minus 1. This is just condition, so I won't change that. This is minus x plus 1 over sine of x minus 1. This is x less than. Very nice. Now, since you see that, to deal with the limit of absolute value of x minus 1 as the sine of x minus 1 as x goes to 1, now I have to separate it into two pieces. Oops, sorry about that. I can do this one. What are the two different pieces? Well, I will do the right limit and I will do the left limit. When we are working with the right limit, so we are basically here. So that means that I will go ahead and find limit. Okay, so this is red. So this will be limit of x going to 1 plus x minus 1 over sine of x minus 1. And let me show you some nice trick here. Limit of 1 over sine of something over that something itself. As you see, x approaches to 1, then x minus 1 will, okay, 1 plus, then x minus 1 will approach to 0 plus. Yes. And here that box is basically x minus 1, which is approaching to 0. Do we know what is the limit of sine box over box as box goes to 0? That is one of the very important facts for our course. Limit of sine of something over the same thing when that something goes to 0 is equal to. And here, what you see, then this will be 1 over 1, which is 1. But for the negative side, you have this piece here. So let me do this so that you can follow that. Hopefully, limit of x goes to negative 1. And here will be minus x plus 1, which is negative x minus 1. I actually had it up there, sine of x minus 1. And this is limit of negative 1 over sine of, again, box over box. What is box here? Again, x minus 1. This time, this goes to negative. And wow, this is always true. See, this is true for the limit itself. So the right limit will have the same number value. The left limit will have the same value. So this will be negative 1 over 1. And that is equal to negative. What can I conclude from it? Right limit, left limit are not equal. That means that this limit does not. So I can conclude from there. Go back. Conclude that this limit does not exist. And then go up. This limit does not exist. Well, this limit does not exist multiplied to a number which is, I don't know, negative 2. So the whole thing does not exist in this case. In other words, the right limit of this guy would be negative 2 times 1. The left limit would be plus 2, but negative 2 times minus 1, which will be 2. So that's why this limit does not exist.